In this video, we are going to talk about transformations, even and odd functions, and inverse functions. And so this is kind of the structure of things. We've talked about A, B, and C before. We talked about it within transformations, and then we talked about it again when we started talking about sine and cosine graphs. And so just like in sine and cosine graphs that we've seen more recently, the A and the D are both vertical things. The B and the C inside the function are horizontal things, and they're backwards from what you think they're supposed to be. So the yellow things are vertical things, and so when A is bigger than 1, it's stretching it vertically. If it's between 0 and 1, it's going to compress it vertically, so it's like 1/2. It's going to be half as tall as it was before. If A is negative, it's a reflection over the x-axis. And so B is all similar things. So like A and B are both multiplied by things. B is multiplied by x, A is multiplied on the outside. And so B is also a reflection if it's negative, but it's over the y-axis. It's a horizontal change. If B is between 0 and 1, it's a horizontal stretch. So we're stretching it out horizontally, which is backwards from what we saw with the A value. So vertical stretch is bigger than 1, horizontal stretch is between 0 and 1. Vertical compression is a fraction, horizontal compression is a bigger number. So it could be 2 or 3 or 4. And so these things behave backwards from each other. Same thing with C and D. These are both added numbers, and so both of these are translations, or shifts left and right, and shifting up and down. And so when it's minus C, it's going to the right. When it's plus C, it's going to the left. Plus D is going up, minus D is going down. Okay, and so this is just one of the examples from our completed notes from this lesson. On this equation, this is a square root function. It's negative. It's x plus 4. So the negative tells me that there's a reflection over the x-axis, and the plus 4 is shifting this graph 4 spaces to the left. And so this was our original function, the red dots. The purple dots was the reflection, and then the green dots is taking the reflected graph and shifting it over 4 spaces. Reflection over the x-axis on this one also has a reflection. There's a 2 on the outside, and so that's a vertical stretch by 2. There's also a plus 2 on the outside, and so that's a shift up. So we reflected the red dots, are my parent function of my absolute value graph. We reflected them, so that became the green dots, and we stretched them. So they're twice as tall as they were before. And then we took all of those green dots and shifted them up 2 spaces. Okay, next we have even, odd, and neither. And so even functions are symmetric about the y-axis. So they reflect over the y-axis. Odd functions, if you take the graph and you rotate it around, so if we take this graph and we rotate this whole graph, is it going to let me do this? Yes. I took this whole graph and I rotated it around. This graph looks exactly the same as it did before. I rotate it back, it looks exactly the same as it did before. And so this is my my odd function. They can rotate. You can also see it as like, what if I reflect it down here, and so now it's here, and then I reflect it again. So 2 reflections or a rotation is going to give you an odd function. So even functions, odd functions, and then if it's neither of these things, then it's neither. So if it's not reflective and it's not rotational, then it is not if it's not a function, it's neither. If it's neither of those 2 things, it's not a function, or it's not an even function or an odd function. It's neither. Okay, the other part of this definition is when the x values are negative and when the y values are negative, when the x values are negative and when the x values are positive, the y values are the same. So like over here, this x value is negative, negative, and this x value is positive, but the y values are the same. And that's true of all of these points on both sides. All the y values over here are the same as the y values over here. Whereas these, when x is negative and when x is positive, they are opposite y values. So these are all positive values, these are all negative values, and so they're opposites of each other. And so this is how this plays out in an equation. So we can plug in negative x. It's always our first step, plug in negative x and see what happens. So when we plugged in negative x on this one, it's to the 4th power, so negative x, negative x, negative x, negative x. That gives me 4 negatives, and so that is a positive. And so the original function has the same signs as the ending function, and that makes this one even. When we did it on this example from the notes, we plugged in negative x, 5 times negative x minus 1. The 1 stayed the same, but the 5 times negative x became negative, and so one sign changed, which is an odd property. One sign stayed the same, and so therefore it is neither, because it did both things at the same time. And then for our odd function down here, when I plug in negative x and I plug in negative x times negative x times negative x is still negative. 2 times negative x is also still negative, and so I went from positive signs to negative signs, and that gives me an odd function. All the signs have been changed. Okay, and then we have inverse functions. And so the big idea with inverse functions is that the y value and the x value are switching places. The original is xy, and now the inverse is yx. It's an inverse function. Everything has been swapped around. It also has reflective properties over the line y equals x. So like whatever's over here is now going to be over here. And so when we're solving, we switch x and y and then solve for y. And so this is how this looked in the notes from this lesson. F of x, we changed it to y just to simplify our letters. So x and y switched places. So now it's x equals y cubed plus 1. And from here, we just solve for y. We follow our algebra steps, and so it's positive 1. And so to move this to the other side, it's going to be minus 1. So x minus 1. And then I'm left with y cubed, and so to get rid of the y cubed, I need to cube root, which is the opposite, or the inverse operation that's going to undo that. And so cube root both sides, and so I'm left with the cube root of x minus 1 all on the inside is equal to inverse y, or f inverse of x is how you read that. So swap x and y in the equation and then solve for y. And for a linear function, same idea. X and y switch places, we solve, so plus 4, divide by 2. You can leave it as one big fraction. You can also split it into 2 fractions, x over 2 plus 4 over 2, which is 2, and 1/2 plus 2. So all of these answers are the same. You can look all sorts of different ways. Any of those answers I would take on the final. And that is where we're going to stop in this video.